problem. Hey guys, so today we are going to be solving this problem 690 employee importance. So let's first understand, let's first read the question and understand what they're asking for and what information we are given. So you're given a data structure of employee information which includes the employee's unique ID, their importance value, their direct subordinates ID. For example, employee 1 is the leader of employee 2 and employee 2 is the leader of employee 3. They have importance value 15, 10, 5 respectively. Then employee 1 has a data structure like 1, 15, 2. So if you look at the definition of employee data structure, you have the ID of the employee first, and then what's the value of the employee's importance, and then you have like a vector of int of the subordinates, which includes the kind of like the ID of the people who work underneath this person. But then okay, so then employee 1 has a data structure like 1, 15, 2, and employee 2 has a data structure of 2, 10, and an array containing vector. And employee 3 has 3 as ID, 5 as importance, and an empty vector. Note that although employee 3 is also a subordinate of employee 1, the relationship is not direct. So now, given the employee information of a company and an employee ID, you need to return the total importance value of employee and all their subordinates. So if we think about it, our first employee 1, that person has importance of 15, and another person works under him. That person's employee ID is 2 and importance is 10. There's another person working underneath him, employee with the ID 2. That person has ID 3 and importance of 5. So even though 3 is not directly working under 1, but 3 is working under 2 and 2 is working under 1. So we kind of have to include 15, 10, 5 because 3 is, indirectly working under 1. So we pretty much just have to like, take sum up all the, sum the importance of the ID that is given, and everyone working underneath him. So to solve this problem, we are going to use recursion. Why recursion? Because we use recursion whenever we don't know how many times we would have to do something. We just have a condition. We know when to stop doing something, right? So, or you don't have the data right now that you would need to do some sort of operations, and until you actually calculate or conduct current operations, you do not have the results to kind of like use it for the next iteration of calculations or operations. So that is when you actually use recursion, which is, I will repeat again, maybe it will sound confusing. You are doing something using some data, and that data for the next iteration of whatever is it that you are doing, you cannot do that until you are conducting the current operation, because the result of current operation will be input or argument for the next iteration of operations. Hopefully that makes sense. So as you can see in our case, we do know that by looking at the subordinates vector of 1, we do know that we'd have to add the importance of employee 2 with the importance of this person, but we don't really know that we would have to add the importance of 3 as well until we actually traverse through the subordinates of 2. So we don't really know how long we would have to kind of like go down the levels. So that is why I'm going to be using recursion. I will also have a global variable called add sum because it was easier to do. I tried to return the add sum in my recursion, and I think I messed up something. I just did not feel like spending time to clean it up. So I'm just gonna use a global variable. Okay, int add sum, return this, and I'm going to call my helper function. Okay, what do I name this function? Yeah, I'll just name it find sum. No, I just call it importance sum because this is the sum of the importance of the first employee ID you're given over here. Importance sum, and I'll just name it add sum. So the parameters will be the vector of employee itself. Yeah, employee pointers actually. Int ID. So yeah, we would have to call the function over here as well. Add some employees ID. So given the vector of employees pointers and the ID, we will traverse through the vector I is equal to 0, I is less than employees dot size I plus plus. We will check if the the employee that each pointer of this vector that is pointing to, if the ID matches to the parameter, the argument ID. So if employees at I dereference set ID is equal to given ID. Not sure if it'll get confused and give me an error because the variable names are same. Let's see. If we found the employee, then add that employee's importance to the importance sum. Employees I, so yeah, into importance. Excuse me. Now I want to check if there's anyone who's working under him. If not, then we want to return because there's just no more employee working under this person and we found the answer already. If okay, all of that needs to happen. All of this needs to happen if we found the employee. So we found this employee, we added this person's importance to importance sum. Now I want to check if there's anyone who's working underneath him. Employees at I subordinates dot size is equal to 0. That means there isn't anyone working under him or her. Return. So you have done that already. Okay. Otherwise, we actually want to traverse through the vector of subordinates and pass their ID to this recursive function so that we can add the important sum of the IDs of the subordinates and everyone working under the subordinates, the current subordinates. J is less equal to employees at I dot, okay, no, I need to dereference it. Subordinates dot size J plus plus add add some employees and ID is employees at I each subordinates. See, no, okay, I am returning important sum, not add sum. Yeah, so I'm traversing through employees, checking if dereferencing the ID gives matches with the input ID. It does. We found the employee, add that employee's importance, and then we are checking if this employee has any subordinates underneath him, working under him. So we do that by checking the subordinate size. If it's 0, that means there is no one working under him. We return, we just break out of the function. Otherwise, we go through, we can traverse through the subordinates, and for each subordinates under the current employee, we call the add some recursive function again. Yeah, let's see if it works. Oh no. Okay, yeah, that was stupid. I should have taken them off. Okay, let's submit and see if it works. Okay, yeah, it works. 89. Okay, nice. Oh, I hope you enjoyed. Thank you so much. Bye.